Welcome to Industrial PLC Applications. This video is on Communications Part 2, Networking. In our last video, we looked at some of the basic hardware used in networking, like routers and switches. In Lab 3, we briefly connected a series of switches, PLCs, and laptops into a simple network, and then had to locate a particular PLC. You may remember some of the confusion and frustration we experienced in Lab 3 with a disorganized, haphazard network. IP collisions and reassignments, connecting to the wrong PLC, or thinking we were on the correct PLC, only to find it was elsewhere. You can begin to see why the IT department can be, well, let's say disciplined and very fussy about who is doing what on their network. Imagine for a minute what could happen in a large-scale industrial plant, where not only the IT department, but the financial, the production planning, engineering, parts and logistics, personnel, and payroll departments, as well as maintenance, all have a piece of the network. And do you really want somebody surfing the net or watching TikTok when you literally have thousands of PLCs, variable frequency drives, robots, motors, conveyors, elevators, paint ovens, heating and cooling, all vying for the same resources? To an IT administrator, you might as well be looking at the entire internet network for Brampton. In order to even begin to sort out network chaos, we need a map, a lay of the network landscape. Well, networks can be configured in different ways depending on equipment, feasibility, and efficiency. These different configurations are called topologies. To begin with, let's take a look at some of the common types of topography that are in use. We'll expand on them a little later. So the first one is called bus topology. It's also known as trunk line. It's a simple system that has usually one boss unit that controls a series of worker units from a main bus that drops to each individual unit as well as the boss. The second is called star topology. It looks like basically a star. You have a central unit and then it spreads out and talks to other devices on its network. A combination of that is called tree topology, where it literally is a bus topology with a series of star topologies attached to it. From that, we can look at an Ethernet network. An Ethernet network is like a star topology, but it keeps expanding and getting larger and larger, so it's closer to a tree topology. Each switch can be a small sub-network. Switches talk to routers. Routers in turn will look at a lot of switches, but it will also talk to a gateway router, which will then expand onto the World Wide Web and to multiple other gateway routers. The last one is called device level ring, and basically it is a system whereby every unit has cabling attached in and out that allows the communication to flow through all the devices. If a part of the line gets severed, the communication is not lost because it can go around in either direction. On any of the other systems, when a communication is severed, from that point on, the network is down. This is a diagram from Allen Bradley demonstrating a small star topology using Ethernet. The PLC in the top left corner is connected to a switch. The switch in turn is connected to a series of Ethernet embedded devices such as the remote I/O blocks, the small mini rack, and 3 safety I/O. The switch in turn is also connected to a router, and information that must be shared between PLCs, say from this PLC to another station's PLC, can be sent and received. And the routers in turn can also be connected to a larger server where production status can be centrally monitored and changes initiated if required. The intent of this video and the information you're receiving in this course is to give you an introduction to different network topologies. If you wanted to become a network specialist, you would have gone into IT. and we haven't the time, even within 14 weeks, to get into a single topology properly. This is merely an introduction to the different types of topologies that are available and still in use. The first one is called loop communication. Loop communication used to have names like token ring and master slave, but the same premises still are involved. Its infrastructure is similar to addressable fire alarm systems. Devices communicate along the same network, and they each have their own unique address. The active stations, system controllers, are colonels or generals. They're in charge. The passive stations are the worker bees. They actually do the work. They're privates and corporals. So the generals give the instructions and ask questions and pulls the network. The privates do the work and answer the questions and send data. On a token ring, nobody can do the talking unless they have the token at any given instant. Trunk line is a topology whereby a main trunk line or bus is run through a section of the plant, and each device has an attaching drop line, hence the name trunk line drop line. Each bus unit or working unit is attached to the trunk via its own drop. The system then works on a token ring whereby an electronic token is passed along to each boss in turn. Only one boss can have the token at a time. Each worker unit on the system does a check-in with the boss unit. If it does not receive a reply or loses touch with the boss after a certain period of time, a watchdog timer, the worker unit goes into safe mode. Each boss unit is given the electronic token that gives it full control of the bus. When the boss has the token, it initiates an exchange of data with each of its workers. Once that is done, it releases the token to the next boss on the trunk. If the drop lines are doubled up, that is, one in and one out for each unit on the bus, and another conductor is taken back to the boss, then the trunk line topology can become a loop system as well. EtherCAT is a complete loop system. With loop communications, just like mail, a large bundle of instructions are distributed to each proper address. This makes EtherCAT a very fast system, occasionally too fast, which requires the system to be slowed down for slower communicating devices. If different sections of a larger network needed to be isolated from other sections, for example, production versus sales, or sales versus engineering, or accounting versus production, you would likely want the network broken into different networks. Unfortunately, doing this can be cost prohibitive, as cabling and equipment would have to be doubled, and then there's all the installation and then setting up. Fortunately, there's a way to use the existing equipment and yet have separate networks. The trick is to set up virtual local area networks, or VLANs. It's the cake and eat it too solution. And the way we do this is we use managed switches. Within the managed switch, an administrator can partition off ports into groups, networking them. Once set up, only devices within each VLAN can communicate with each other. For example, both of the switches shown in the diagram have set up 2 VLANs, so we went from one large network to 4 small subnetworks.